Hey there, CJ Messins. I'm going to help you out with homework 9.2, distribution and display. So this first question, or set of questions, this has to do with this dot plot over here. So it says how many residents were surveyed. In order to find that out, basically what I do is count up all the dots I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 residents surveyed. Number 3, what is the greatest number of pets owned? Well, I can obviously see that 0 is the least number of pets owned. The greatest number of pets owned is not looking at this distribution, but saying that, oh, somebody owned 6 pets. They were the person with the greatest number of pets. So 6 pets was the greatest number, not 2. That just means there's a whole bunch of people that own 2 pets, right? Oops, sorry, I meant to go on question 3 there. So 6 pets. Number 5, how many people owned 4 pets? So I go to 4 and I say up 2 dots. That represents 2 people. All right, I'm going to help you out with 6 here. If a new resident moves into the neighborhood and they own 6 pets, so just imagine you add somebody over here, how does this resident compare with the rest of the neighborhood? You could say they are well above the average number of pets owned. Right, the center of this data is around 2 or 3 here, and they're all the way out at 6, so they're like an outlier. All right, I'm going to help you fill out the frequency table and dot plot for these. And it's a little tedious, but then there's questions to them on the end. So first one is creating a frequency table for the hours watched for TV. So you talk about hours over here, you talk about your tally mark here, how many people did it, and then creating that tally into a number in your frequency. All right, so there's that, and then we'll go ahead and draw nice columns. And we can go ahead and say, all right, we look through here, we say it starts at 3, looks like it ends at 12. So 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And basically you'll now want to draw your horizontal rows just to divide that stuff up nice and evenly. All right, so after we get done with that, we're going to go ahead and look and see, all right, how many people, or how many 6th graders watch TV for 3 hours? And I can calculate 1, 2 right there. 1, 2, and say frequency of 2. How many people watched 4 hours? Nobody. So I can just put a frequency of 0. I don't put any tally marks. There was 1 person that watched for 5 hours. There was 1 person that watched for 6 hours. There were 2 people that watched for 7 hours. There's 2 people that watched for 8 hours. There were 4 people that watched for 9 hours. 2 people that watched for 10 hours. Nobody for 11 hours. Oops, that shouldn't be a 10, that should be a 2, my fault. And then 1 person at 12 hours. Okay, so there's your frequency table. Again, the questions on the back will ask you about this. So now we'll do the same thing, but this time a dot plot for this data. So the number of students in 10 kindergarten classes. So again, let's start with the range. We say, all right, our lowest number is 18. It looks like it goes all the way up to 24. So 18, 19, 20, 21, 22, 23, and 24. So how many people, or how many classes had 18 students? That's 3 classes, so put 3 X's. Nobody had 19, so no X's. 3 more classes had 20 students. Oops. 1, 2, 3. 1 class had 21 students. 1 class had 22 students. 1 class had 23, and 1 class had 24. Okay, so there's your dot plot. So now you have to go back and forth with these questions. I'm going to help you out with some of the odd questions here. So what was the greatest number of hours of TV watched? So go back here and say, okay, frequency, nope. You're thinking about the guy that watched the most TV, not the most people who watched a certain number of hours, just the greatest number of hours watched. It was 12 hours, right? So 12 hours. And here was the greatest number of students. It's not the class that was the most popular, like 18, 20. It's the class that had the most students, which was 24 students. All right, so these questions are very specific. They just want to know basically what's the maximum in that data set, right? Question 5, another student agrees to watch 9 hours of TV. Would this change the data? You kind of have to know about question, or the center, I guess, in this question. So the center of the data seems to be around 8 or 9. And so adding another student with 9, no, it's not going to change the center. This would not change the center. The new data is added near the center. All right, so just telling you, hey, I got another person that watches 9 hours of TV. Well, that's already kind of our popular pick anyway. What about number 5? Another classroom of 15 was included. With this change of the data, why or why not? So 15 be all the way over here, right? So is it going to change the center? We'd have a new low. So we would have a new low, but it wouldn't change the center, right? 20 students is still kind of the popular pick, is still the center of that data. It wouldn't change the center, right? The center is just another name for median, right? We discussed that in class. So like if you just start crossing off, you'd say 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. I mean 20. A data point that's in 20 is still the center. Okay. All right, number 7, let me show you how to do these problems. So you got movie and the number of awards they won. So basically it's already nice and neat in order. You just go ahead and tally, okay, I got 1, 2, I got 1, 3, I got 2 4s, I got 3 5s, I got 1 6, and 3 7s. So basically you're just looking at the dot plot that matches that. So go through here. This one has 1 7, B's out. This one has 2 7s, out, right? This one has 3 7s, good. It has 1 6, good. It has 3 5s, good. It's got 2 4s, good. There you go. D is not your answer. It does have 3 7s, but it has an 8. We didn't even have an 8. Also doesn't have 6, and we had 1 6. So there you go. So that's how you do problems like 6 and 8. All right, that's it. Call me if you have questions.